doctor, we can leave your friends behind, cause your friends don't die.
Hello, I'm Emily, the newest host for Physics is Fun. Dr. Shadow Robinson has taken a trip to Mars to pursue his interest in researching where the human race will live after the Earth can no longer sustain us. I'll be gone by then, so who really cares? Now, today on Physics is Fun, we have an electrical expert with us that is here to explain the safety and physics behind electrical circuitry. Here she is now, Dr. Sarah Nellen. Genius! Welcome, Sarah. How are you?
Thank you. I'm great. I'm just keeping up with all the research. I'm working with Dr. Robinson to figure out where our electrical power will come from when we live in space.
Oh, how interesting. So what exactly have you come to talk to us about today?
Well, today we will be discussing some basics on how to avoid a circuit overload. This is a common problem that can be very dangerous, yet easily prevented.
Alrighty, well, let's get started. First of all, what exactly is a circuit overload?
Well, a circuit overload is when an electrical wire carries more current than it can safely handle.
So what causes the wires to receive more current than they should?
There are two main causes of circuit overloads. The first cause may be that there are too many devices plugged into the circuit. In this case, the multiple appliances cause too much current to be drawn through the wire. This would be an example of too many appliances plugged in at once, like this.
That was a mess. I don't want my stuff looking like that.
The second cause is a short in the circuit, which may be caused by eroding or loose wires in the circuit, like this one.
Oh, that looks gross.
Shorts decrease the resistance of the wire, which causes the current through the wire to increase above its safe value.
Interesting. That's good to know. But how do I know what is too much or if I have a short circuit?
If you have plugged in too many things, or if you have a short circuit, your circuit breaker would trip.
Oh, I know what those things are. They're those nasty looking gray boxes on the wall with a bunch of switches inside them, right?
Yeah, that's right. Would you like to know how they work?
Well, duh.
Okay, geez. Each circuit breaker acts as a switch within the circuit. They have a maximum amount of current that is allowed to pass through them. If the current passing through the breaker exceeds this limit, then the breaker opens and the circuit becomes incomplete, which prevents any current from being withdrawn, and everything plugged into that particular circuit will no longer work.
Oh, so that's why all the lights go out when I'm trying to blow dry my hair, microwave my chip bags and my dinner in two separate microwaves, watch TV, and listen to the radio all at the same time in my bathroom.
Yeah, that would definitely be the reason. I can't believe you do all that at once. That's so dangerous.
What do you mean dangerous? The worst thing that's ever happened is the lights go out. That doesn't seem dangerous to me.
Oh, well, that is dangerous. With all the current that you are pulling through the circuit, the wires in your wall could heat up and cause a fire. This is especially dangerous if you have too many things plugged in your house.
Alright, I get it. So what can I do to figure out how many things I can plug in?
There are some simple formulas that are easy to remember that you could use to determine how much current your appliances will draw from a circuit. You can obtain all of the variables by checking your appliances to see how much power they draw and checking each breaker to see how much current they allow to pass through them. The first column of formulas describes the relationship between current, voltage, and resistance. The second column relates the power to current, voltage, and resistance. With all of these formulas, you should be able to figure out what your circuits can handle.
But what if I'm not good with calculators and formulas and stuff like that?
You can always ask your local electrician to come by and check your circuits to ensure that they are working properly. They should be able to tell you what type of things are okay to plug in where.
That sounds easy enough. I think I can handle that.
I have full faith in you, Emily.
Well, Sarah, thanks so much for joining us today on Physics is Fun. I had so much fun learning about electricity.
It's been my pleasure. I'm so glad I was able to inform you and your viewers of some easy ways to prevent dangerous electrical accidents from occurring.
Well, that's all we have for you from Dr. Sarah Nellen. Now, for the physics tip of the day. If you ever happen to be in a vehicle that gets struck by lightning, remain calm. Do not touch any part of the car that is metal or part of the frame of the car. If you can open the door without touching the frame or metal, do so. Then jump out of the car, straight onto the ground, and continue to avoid the car until you know all of the electrical energy has been discharged to the ground. Thanks for watching, and tune in next time to learn how to prevent yourself from being sucked into a black hole.
Dance, and if they don't dance, well, they're no friends of mine. I say we can go where we want to, a place where they will never find, and we can act like we come